Hi everyone, welcome to my session. My name is Ashes. I work mostly on node operations repair and gossip in Scylla. In this talk, I will walk through some of the improvements we have made since last summit and some new features we are working on. Maintenance operations like repair or add node are important jobs to operate Scylla. Those operations usually require significant data movement between nodes. It is not an easy task to make those operations efficient while maintaining minimal impact on your workload all the time. So we set a goal to streamline all those operations and make operating Scylla as easy as possible. Scylla scales pretty well both horizontally and vertically. Users enjoy the performance of Scylla. However, Scylla maintenance still has some rough edges and we can do better. For example, seed nodes have special roles in the cluster and we have special procedures to operate. It is complicated to remove load, especially in case of error. Operations that take a long time to finish are not reasonable, and the aggressive compaction makes add node operation take a longer time to complete. We have plenty of improvements to help. Now I walk through some of them. Seed nodes are selected by users to help the discovery of the cluster and the propagation of gossip information. However, this special role breaks the lies every node is symmetric architecture. More importantly, we need special treatment and procedures for operating seed nodes. Recently, we removed the concept of seed node. The seed option is kept for compatibility, but we changed the meaning. It now serves as a contact points to existing nodes in the cluster, and the seed option will be used only once when adding a new node into the cluster. After that, we can forget about it. With this feature, now seed node always bootstrap, and the dangerous auto bootstrap option is ignored, so there's no more confusing why no data is synced to the new node. Also, no need to replace a dead seed node or promote non-seed to seed node, and more. Though network repair is introduced to replace the old partition network repair, it has much better performance because it repairs at the granularity of row instead of partitions. We continue to improve it. In recent Scylla, repair will generate next access tables during repair operation. This means next access tables and next compaction, so better repair performance. We also improved the latency impact during repair. For instance, we featureized more time-consuming functions to avoid stores. We also switched to use B-tree set to store repair hashes to avoid big memory allocation to reduce latency. To make it easier to identify repair job, each job is now attached with a UUID. We added an synchronized API to check the status of repair, which makes Scylla Manger more efficient. We added more metrics to report the progress of repair and other operations, so you can check it on Scylla Monitor easily. Since now the repair is pretty efficient, on top of that, we introduced the repair-based node operation. The idea is to use repair as an underlying mechanism to sync data between nodes instead of using streaming. Yes, now we can use repair to implement all the node operations. What are the benefits? First, it makes node operations reasonable. For example, when you add a node and it fails in the middle. In the past, when you add the node again, it will sync all the data again. With this feature, we can resume from where it failed and skip syncing the data that the node already has. It makes the operating safer in terms of data consistency. The repair guarantees the latest replica is synced between nodes. For instance, when you run replace operation, the replacing node is guaranteed to have a latest replica instead of a random replica that is streamed from one of the replica nodes. It also makes the operation faster and simpler because there's no need to run repair before or after load operations. It is faster to run a single operation than two operations. It unifies all the operations to use a single mechanism to sync data, so the code base is simplified and nicer. Replace operation replaces the dead node in the cluster. It is one of the most common operations to recover a broken node in the cluster, so we want to make it as efficient as possible. This is what we do before. The replace operation takes time to sync data to the replacing node. The time depends on the size of the data. During this time, the replace node takes no writes. This means the replacing node is missing all the writes during the operation. As a result, repair is needed after the replace operation is done. Can we do better? Yes. Recently, we changed the replacing node to take writes, so no writes will be missing during the operation. In addition to that, repair-based node operation feature ensures that the node has the latest replica before the replace starts. With the two features combined, we can get rid of the extra repair needed for replace operation. Removenode operation removes a dead node from the cluster. This operation is originally supposed to remove a node out of the cluster as soon as possible. So if it will succeed, even if part of the data owned by the removed node has not been synced to the new owners, this might cause data consistency issues. In Scylla 4.4, we made a big change to the remove node operation. Now the operation runs in the safe mode by default, so remove node will fail if the operation is not safe. For example, some of the new owners are not alive or the syncing of data has failed. Beyond that, we made the operation more resilient in case of error. That is, the cluster will automatically revert to a previous state in case of failure, as if the operation had never run. This makes it much easier and safer to use in production. Off-strategy compaction is my favorite. This idea is to make compaction during those operations more efficient to speed up the operation. Access tables generated by operations in a separate dataset only compact them together when the operation is done. Then integrate the new access tables into the main set. It is more efficient this way than adding the new access tables into main set as soon as it is generated. The access tables generated have two important properties. First, they are disjoint. Second, they are new data to the node in both cases. Those two properties ensure the read amplification is limited even if without compaction. That's the reason why we can delay the compaction while not having big impact on the read performance. As you can see in the graph, we have zero compaction during the operation. In addition, we made the compaction triggered by operations run under the maintenance scheduling group, meaning it will have minimum impact on your CPU latency. In summary, this feature will make it much faster to run remove or add operations. This feature is about giving users more control on the intensity of node operations by limiting the disk bandwidth and IOPS. As you can see in the graph, the disk bandwidth of replace operation is kept nicely. In addition to Scylla core improvements, we also had cool improvements in Scylla Manger. Limited backup bandwidth to have less impact on your workload, deduplication at the file level to reduce backup size, run Scylla Manger and the agent under C group to reduce impact on Scylla core. We also made the Scylla Manger run faster for repairs. It can run repair jobs on multiple loads in parallel in a smart way. You can now adjust the repair intensity and the repair speed in flight. In this talk, we covered the recent maintenance improvements. It is not the end of the story. We will continue to invest more to make operating Scylla as easy as possible. For example, the feature to add multi-nodes in parallel, use Raft to do schema and topology change, and more to come in the future. Thanks for joining. If you have any questions or suggestions, feel free to reach out to me.